Here we go. So I put in something pretty darn similar to what we had on the board, right? Pretty darn similar to the kinematics equation.
Yeah, that should work.
So here's G, things like that. So I'm going to go ahead and press play. And what we should see, by the way, so the goal here is to get it to look like this. So it's supposed to look something like that.
Just like Angry Birds.
Right, exactly. And so when you hit the space bar, beautifully lines up.
Yay.
Because we know how to draw our trajectories correctly and things like that. So that's the goal here. So this was my first guess at what to do. So I don't know if you can show them the code here. So I've got, let me make this bigger.
So we have our x draw is x odd plus vx times t, as what we shown earlier. And then we have our y odd be y odd plus vy times x plus 0.5. Where did the 0.5 come from?
Well, it's a half.
Of course. Got to make sure.
Don't forget that part.
Yeah.
Yes.
And then we have our g here, and then times t squared. Yeah.
Right. Now, I'm not guaranteeing that this is going to work, right? So I said that like a couple of times. But so let me zoom out a little bit here. All right. So you notice now I'm pressing play here. We do not see this beautiful trajectory like we see, you know, over here. Whoops. Like this one. So that's what we're supposed to see. But instead, we don't even see that.
Yeah.
If anything, we see this little tiny dot right there.
Right, just one dot.
Okay. So here's one of the things that you can get wrong with this, which is that in many, if not most, computer languages, you can't do this caret 2 thing to square.
It's not a thing.
It's not a thing. So instead, you just want to do t times t. Okay, so that's going to be a little bit better. And so now I can press play. And actually, let me go back and let me put that back. All right, t caret 2. Again, I'm going to prove that this doesn't work.
Yeah, it's
and then when I do that, all kinds of craziness ensues.
Yeah,
that line shouldn't even be moving. Like if you saw the other one, it's supposed to just stay there.
Yep.
And the thing is flying on top of it. Yeah. More or less.
It was like, no, we're going to do what we're going to do.
Right, so I'm just going to change that to t times t. That should be an improvement, I guess. So now I'm going to do this, and now it does that.
Yeah, it doesn't even stick.
So
sad face.
Let me do it. So this actually is a little bit closer than what we were. So I'm going to play it back again, and you guys can see. You can see this. So now if I do this, there's this brief moment in time where it actually does work. Okay, so I hit the space bar.
For the couple seconds, yeah.
For there's just the split second, it's beautiful, and then it moves, and it gets all weird again.
Yeah.
So what's happening is that we're not supposed to put Vx and Vy here.
Oh.
Do you see that? Can you move over there for a second?
We're not supposed to put Vx.
No.
Oops.
And the reason that we're not is because Vx and Vy are changing. Whereas in this other equation, you know, when we had on the glass board, that was the initial Vx and the initial Vy.
Right.
So we got to replace this with the initial Vx and the initial Vy. And I know someone who just did a bunch of trigonometry.
I did.
To figure out what that should be.
So our Vx, which you remember, is cosine.
The initial Vx.
Yes, the initial Vx. Cosine theta times Vinit times t.
Looks good.
So then our Vy, again, if you need help or you're like you just don't remember, they are right here. They're the same functions. So then we're going to do, instead of Vy, we're going to do sine theta times Vinit times t.
Okay. Let's give it a try and go ahead and zoom out a little bit so we can see the whole thing.
Let's do this
I'm really excited about this one. I think this is going to work.
I bet 3 M&Ms it works. 3, something. Hold on, wait. Oh, wait. Pause.
Okay, all right. Did you see what happened
there for
a second? So
like
hit play again and then hit up arrow.
Yeah. It just kind of, I'm making it go fast.
It's still planetoids. Like all the planetoids code is in there. We haven't hit spacebar yet to turn on gravity.
Yeah.
So if you want to disable all the planetoid stuff, you can go to the beginning and set F thrust to 0. That way it's not a rocket anymore. It's just something that's getting fired off. See?
There we go.
So if you press up arrow,
nothing happens.
Nothing happens.
It's all normal. So let's change the trajectory.
Oh, it's a straight line. It's not. It's supposed to be curved.
Sad face. Well, let's just play it and see if it changes.
Okay.
See if it fixes
Go ahead
his
and
life.
hit spacebar. See what happens.
Wait. It does something.
There we go.
Yay!
So that looks good.
Yeah. So when it plays, it does it.
Right. So something happens when you hit spacebar.
Gravity.
Gravity.
Eureka.
Okay. So how do we go back to this code and try to make sure that... Because we wanted to do this from the beginning.
Yeah.
So let's look at the code real quick and try to figure out what happens.
So since we wanted gravity to be accounted for in the beginning, would we change this g equals 0 function to negative 9.8?
No, that's going to cause it to fall immediately.
We don't want that.
You
Don't do
leave that to be 0.
Oh, wait. I know what we have to do. It's in our steps.
Is it?
I think so, yeah.
I think we just make the... I think I don't actually tell them that this is a thing.
He is correct.
All right, let's look at the code real quick. Let's see if we can figure out what this little trap I've left for everyone.
This little trap I've left.
Okay, so we have...
Something tells me it has something to do with this area.
Something's wrong. Okay, so you see this G here? Initially, what is G?
0.
So initially, that's 0.
Yeah.
Even though we kind of want this to be 9.8 here, right?
Correct.
We're on negative 9.8 technically.
Yeah, it's going down.
So what's happening, I think, is that initially, before we hit the spacebar, G is 0, and we just get a straight line out of this, which is basically what, like in Planetoids, it would do, just move a straight line. And so if we replace G here with negative 9.8, like just the number, like no variables, then it should work.
Okay.
So maybe give it a parentheses and a negative 9.8. There you go. Well, let's try that.
Yay. Okay, let's see. So let's play here. Let's give it a nice little, nice little angle.
There you go.
Yay.
That's beautiful.